Maths AA Standard Level End of Year Exam June 2023 Paper 2. In this question give all answers correct to 2 decimal places. This is because we are dealing with money. Sam invests $1,700 in a savings account that pays a nominal annual rate of interest of 2.74%, compounded half yearly. Sam makes no further payments to or withdraws from this account. 1A. Find the amount that Sam will have in this account after 10 years. You should do this question best using your financial solver on your GDC. You need to enter the following amounts. N is equal to 10 because we have 10 years. The percentage rate is 2.74%. The present value, you can enter this positively or negative, and it's $1,700. The future value should be left blank because that's what we want to find. The payments per year is 1. The compounds per year is 2 because it is compounded half yearly. When you've entered these, highlight the future value, press enter, and you should get a value of $2,331.71, which is the value after 10 years. David also invests $1,700 in a savings account that pays an annual interest rate of R%, compounded yearly. David makes no further payments or withdraws from this account. 1B. Find the value of R required so that the amount in David's account after 10 years will be equal to the amount in Sam's account. Again, do this using your financial solver. So again, N is equal to 10. The percentage rate is what you need, so leave it blank. Your present value is plus or minus 1,700. The future value, again, is plus or minus 2,331.71. Remember, if the present value is positive, the future value should be negative. The payments per year this time is 1. Again, compounds per year is this time 1 because it is compounded yearly. Then go back to your percentage rate, highlight it, press enter, and you should get a value of R is equal to 2.76%. The first two terms of a geometric sequence are U1 equals 2.1 and U2 is 2.226. Find the value of R. Well, R is equal to U2 divided by U1, which is equal to 2.226 divided by 2.1. So R is equal to 1.06 using a calculator. 2B. Find the value of U10. Well, U10 is equal to U1 times R to the 9. So U10 is equal to 2.1 times 1.06 to the 9. So U10 is equal to 3.54790, which equals 3.55 to 3 significant figures. 2C. Find the least value of n such that the sum of n terms is greater than 5,543. Well, s to the n is equal to u1 times r to the n minus 1 divided by r minus 1. Therefore, s to the n is equal to 2.1 times 1.06 to the n minus 1 divided by 1.06 minus 1. Therefore, you get 2.1 times 1.06 to the n minus 1 over 0.06, and this has to be greater than 5,543. Therefore, 2.1 times 1.06 to the n minus 1 has got to be greater than 332.58. Here you have an equation which you can graph. You could write it as 2.1 times 1.06 to the x minus 1, and you want to know when it is equal to 332.58. If you open a graphs page, I've changed the window so x goes up to 100 and the y value goes up to 400. I've typed in the equation 2.1 times brackets 1.06 to the power of x minus 1. If I now press enter, it should draw me the graph. So there's my graph. Now I want this value to equal 332.58. So if I go tab, type in 332.58, enter. I now want to know the point of intersection. So if I go to menu, analyze graph, intersection point, somewhere to the left, somewhere to the right, I get a value of 88.333. Normally, you would round that to 87, but because we're dealing in years, 87 is too small, so the value is 88. Therefore, n is equal to 88. A company produces bags of sugar whose masses in grams can be modelled by a normal distribution, with a mean of 1,000 and a standard deviation of 3.5. A bag of sugar is rejected for sale if its mass is less than 995 grams. 3a. Find the probability that a bag selected at random is rejected. First thing, draw yourself a little diagram to show the information. So here's our normal distribution curve. Mean is 1,000. Standard deviation is 3.5. 995 is to the left of 1,000. So we want this area here. So we want the probability that x is less than 995. So we use our GDC. So we want a normal CDF, where the lower bound is minus infinity, the upper bound is 995, the mean is 1,000, and the standard deviation is 3.5. If we use our GDC, we will find that the probability that x is less than 995 is equal to 0.0766 to 3 significant figures. 3b. Estimate the number of bags which will be rejected from a random sample of 100 bags. So in order to find the estimated number, it's the probability, which is 0.0766 times 100, which will, when multiplied, will be 7.66 to 3 significant figures. 3c. Given that a bag is not rejected, find the probability that it has a mass greater than 1005 grams. You must recognize that this is conditional probability. So we want the probability that x is greater than 1005 given that it's not rejected, so that means that x is greater than or equal to 995. That is the same as the probability of x is greater than or equal to 995 intersection that x is greater than 1005, which is basically the probability that x is greater than 1005 divided by the probability that x is greater than or equal to 995. Again, use your GDC. The probability that x is greater than 1005 is equal to 0.07675, and the probability that x is greater than or equal to 995 is equal to 1 minus 0.7675. So the probability that x is greater than 1005 given that x is greater than or equal to 995 is equal to 0.0765 divided by 1 minus 0.7675, which is equal to 0.0829 to 3 significant figures. It just happens to be that because the normal distribution is symmetrical, 1005 has the same probability as 995. This does not always happen. A healthy human body temperature is 37 degrees centigrade. 8 people were medically examined, and the difference in their body temperature in degrees centigrade from 37 degrees centigrade was recorded. Their heartbeat, beats per minute, was also recorded. We have the information in the diagram supplied. 4a, draw a scatter diagram for temperature difference between 37 degrees centigrade on the x-axis against heartbeat on the y-axis. Use a scale of 2 centimeters for 0.1 degrees centigrade on the horizontal axis, starting with a temperature of minus 0.3 degrees centigrade. Use a scale of 1 centimeter for 2 heartbeats per minute on the y-axis, starting with 60 beats per minute. You should get the following diagram. The regression line should not be drawn at the moment because you have to find the mean point for your x value and your y value, which you will find in parts 4b to 4f. Parts 4b to 4e will all be used and completed using a GDC. For questions 4b to 4e, we're going to use our GDC. So you need to open your GDC at a spreadsheet. In column A, which you've called X, we're going to put the temperature difference from 37 degrees centigrade. In column B, which we've called Y, we're going to put the heartbeat. So I've put those in. Now highlight a spare cell. I've highlighted C1. Go to menu. We're going to go to statistics. Statistical calculations. We've got two variable statistics. So our X list we called X. Our Y list we called Y. Everything else can remain the same. Press OK. And there you can see we have X bar, which is 0.025. We can go down. We've got Y bar is 74. And if we keep going down, we've got our R value, which is 0.086. So there is all the information we need to answer 4B, 4C, 4D, and 4E. From the GDC, you find that X bar is equal to 0.025. You find that Y bar is equal to 74. For part 4D, you plot those on the scatter diagram, which I have already done. And for 4E, you find that the Pearson correlation coefficient R is equal to 0.807. For parts 4F and 4G, you will also use the GDC. It is important that you do not re-input the data because that will waste time. For 4F, we're going to use exactly the same information that we've already got in our spreadsheet to find the regression line equation. So go to menu, go to statistics, statistical calculations, linear regression line, mx plus b. Again, our X list is X, our Y list is Y. Everything else can stay the same. And there is our information. The gradient of our line is 21.982, which we will round to 3 significant figures. Our y-intercept is 73.5 to 3 significant figures. And again, we've got our R value, which is 0.807 to 3 significant figures. The correlation is best described as moderate to strong positive. And the equation of the regression line is y equals 22.0x plus 73.5. A function f is given by f of x is equal to brackets 2x plus 2, brackets 5 minus x squared, 5a. Expand the expression for f of x. Well, if you expand that, you get 10x minus 2x cubed plus 10 minus 2x squared, which simplifies to f of x is equal to 2x cubed plus 10 minus 2x squared. 5b. Find f dash of x. So you want to differentiate f of x. When you differentiate f of x, you get f dash of x is equal to 10 minus 6x squared minus 4x. The graph of g of x, which equals 5 to the power of x plus 6x minus 6, intersects the graph of f. 5c. Write down the coordinates of the points of intersection. So if we open ourselves a graph page and type in our two equations, so the first one is brackets 2x plus 2, open brackets, 5 minus x squared, so 5 minus x squared. Press enter. So there's our graph. Now press tab, type in our second one, which is 5 to the power of x plus 6x minus 6. Press enter. We can't see the point of intersection, so I'm going to change my window. So menu, Windows zoom, Windows settings. I'm going to go up to y equals 30. Enter. And I can see my point of intersection now, so I'll get that out of the way. I'm going to go to menu, analyze graph, intersection point, slightly to the left, slightly to the right. So my intersection point is x equals 1.49, y equals 13.9.
So my point of intersection is 1.49, 13.9.